Thank you very much. Thank you very much for the introduction. Thanks for joining me. So I'm Theo, as said, I'm part of the technology and incubation program of T-Systems, which is the IT services part of Deutsche Telekom. And I'd like to invite you today onto a little bit of a, let's say, almost like a history lesson of our quantum program so far, and how we are dealing with the balance between the enormous potential that quantum computing and quantum technology has, but also the economic expectations that we are, of course, always dealing with in industry, which in this case, of course, is mainly return on investment. So we have seen, I think, slides like these a lot of times today and also throughout the last years in quantum computing. And I think we can all agree that quantum computing, of course, is an exciting technology with very exciting application areas. I think the more high level and the more, let's say, public media we go, it's always sometimes even covered as some kind of sci-fi technology which will revolutionize the world. But in any case, I think there are, of course, even the nature of the problems that we are looking here, which are not classically solvable, makes this technology very, very exciting to investigate. And of course, a lot of these use case areas also have quite deep connections to the core business of telecom or the telco industry as a whole. So we are, of course, not that much into material science, but especially the combinatorial optimization part of use cases, but also from a telco perspective, we of course are heavily invested into making our data transmission safe, even in the age of scalable quantum computers, where Shor's algorithm might be able to threaten that. And with these motivation, in 2019 already, we started our first quantum research group. So I was still a student back then, working at T-Labs, which is the internal R&D for the whole group. And together with a couple of mainly physicists back then, we joined our first research projects, which were mainly based on, again, combinatorial optimization. So how can we solve some network issues that we have, and it was back then it was mainly about quantum annealing and Kubo-based combinatorial optimization. And in 2021, the Telecom and the T-Labs also built the first prototypes on the countermeasures of the security threat of quantum computing. So we built we joined some research projects on quantum key distribution and also the post-quantum cryptography, so the, let's say, software solution to the quantum threat. And just a year later, when I also joined the T-Systems team on quantum, we thought of, okay, taking the insights that we got from our research projects and put them into the IT services units at T-Systems. So we focus a lot on use case evaluation. So from the lessons we have learned on combinatorial optimization problems for our own network, what does that mean for all kinds of other industries that we are working with at T-Systems? We also joined QTech in that year, which I still think is a very, very great way for industry to have a, let's say, an open forum to discuss the progress and translate, let's say, academic research into something that resonates with industrial priorities. On the quantum safe side, we opened the Quantum Lab in 2023, which is a connection from our Berlin office in Schöneberg. Whenever you step by, you are invited to look at it in person. So it's basically it's a room of servers which combines entry gates for a lot of our quantum safe projects, a lot of the hybrid solutions on quantum security, but also we are looking into more long-term stuff there. So for example, to use quantum entanglement as a resource for communication within our network. And what are we doing today? So of course, what I also just talked about. On the quantum secure side, we realized quite quickly that the race between QKD and PQC will be very important to us, and of course both technology domains have their unique selling points. So in the quantum lab and in the T-labs in general, we are still looking for innovative ways to combine the software and the hardware solutions to the problem and come up with all kinds of crypto agile protocols, which of course the core motivation here is to make our network safe, to make communication safe, but also, as I said, to look at more, let's say, experimental, more research-driven activities, how quantum technologies could also make the communication more resilient and more performant. When we talk about computing and the progress in computing, so to get this out of the way first, I'm still very much an optimist when it comes to quantum computing, but I think this is the hype cycle for compute published last year, and I think it summarizes quite well in the large discrepancies that we sometimes deal with when it comes to quantum computing in industry. So what you see here is the typical hype cycle and also an expectation when this economically driven study expects quantum computing to reach the plateau of productivity. And I think being on the beginning of the disillusionments with an expected plateau within 10 years, that's quite of a kind of a difficult situation that we are in right now. And I think, and of course, again, this is just an economic perspective, and I think we have seen some great progress in the quantum computing industry in the last 1 and 2 years. But I think, for example, the Google one last year, end of last year, was a good example where I think we are a little bit in this situation sometimes, when there was an exciting experiment showcasing that quantum error correction actually works and that it scales efficiently, but the media headlines were full of quantum computer solved a problem that would take a supercomputer 10,000 years to solve, which is, of course, an interesting headline, but I think this summarizes quite well that the messaging of quantum compute is sometimes quite difficult. And the consequence of that for us in industries is that we, of course, get questions from more management and more financially driven people. When is there a return on invest? So when can we see quantum computing applications that actually make a difference in practice? And I think the question of quantum advantage became a very interesting one in the last years. So from my perspective, it was often, from more pessimistic people, it was often framed as a hardware challenge. We will never have a scalable quantum computer. Now, from my perspective, it got a little bit more of a software or an algorithm question. So when we have a scalable quantum computer, what is it what we actually will be doing with it? And I think this is a great perspective that the quantum computing community has now. Just recently, there was a new paper released by John Preskill and a couple of other very interesting quantum computing researchers, which looked at quantum advantage more from a nuanced perspective rather than the typical I am taking the complexity theory, comparing the algorithms, and that's where I will have my quantum advantage. And I think this is a very important step that we will have in quantum computing, and also for us in industry makes it, of course, much more easy to explain where to look at. So I would say it's on us how difficult this hype cycle perspective from the economic perspective really is at the end of the day. So how are we dealing with it from our, let's say, more application-oriented perspective? So I think it was very, very well covered already today for those of you who have been here at the talk, in the talk of Porsche Digital, because this is, I think, a very, very similar approach. So for us, we think the best balance between the long-term potential of quantum computing, but also the often misunderstood perspective in short and midterm, is to use outcomes of our quantum computing research projects or application use case projects and apply it through technical or classical bridging technologies. So as everyone else, I think, in industry, we started with some enablement first, which for us was, as I said at the time back in T-Labs, where we also looked at plane complexity theory, where do we have complex optimization problems, and which quantum algorithms would be suitable for them. But the gap between these very, let's say, easy use case identification projects and the scalable quantum advantage that we will see in a matter of years, hopefully, is of course still a big one. And what we have done then is to use the models, mainly QUBO-based optimization models in that case, and applied it using classical bridging technologies. This is a use case that really sparked then the interest of our management and also made this quantum-inspired bridging strategy work. So this is one of the problems we identified together with a partner in our network optimization domain. So we have, whenever there's a new, let's say, expansion of a mobile network cell, we have different new towers to place. We also have antennas to adjust, both in terms of frequencies and the antenna alignment. And this, of course, has quite a steep combinatorial explosion pretty fast, because for every tower you have, in that simple example, 3 antennas, which you can then adjust in different angles with different frequencies. So there are a lot of valid but not optimal solutions. And in that case, we use the quantum-inspired optimization solver to turn the QUBO model that we initially used for quantum annealing, but also the gate-based quantum optimization algorithms. And we have been able to outperform the classical in-place baseline that the colleagues used in their planning software. So, of course, we didn't go to our management and say, look, we found quantum advantage, all problems solved. So it's again a very, very tricky question of messaging here. But of course, it's very easy to explain the worth of these activities, even though the technology is not ready yet. And this is also the path we are still taking today. So this use case is still a couple of years old. So this was basically, as I said, the spark for management interest that made us able to justify our investment of time into quantum computing. And now, in the next phase, we are actually trying to integrate this into a more, let's say, conventional IT workflow process. So we are part of a larger European Cloud Edge Continuum project, where we are now using the outcomes of this quantum-inspired optimization techniques and, let's say, use it in a productive environment. So how to deploy quantum-inspired optimization, where to deploy quantum-inspired optimization, what are conditions and constraints that industrial users have that we are not touching when we just use the plain prototyping QUBO pipeline. And we think this is another great step of using something that came out of a quantum computing research project and apply it into at least a bridging advantage today. So this is coming to the takeaways already. So My final message is that we are, of course, not skeptical of the potential of quantum computing in general, but we've noticed quite early that depending on, let's say, the organizational setup, so for example, with the communication projects in T-Labs, it's not that much of an issue, but from an industry application perspective, so things or use cases that we deal with in T-Labs, expectation management really is the key. So we have still a lot of people approaching us with quantum computing in mind as the ultimate general purpose accelerator, which is of course very, very dangerous for the expectation on use cases. And the combination of selecting useful bridging technologies and apply them into flagship projects that also have tangible outcomes, even though they might not be quantum today, is for us the best way to balance the potential of the technology with the progress in current situation in a pragmatic way. And with that, I'm happy to answer any questions. Thanks for your attention. Please feel free to step by in our booth if you have any more questions or comments. And yeah, thanks for having me.